So thank you all for coming in here and withstanding the increasing pressure to learn more about event sourcing and stuff. So it's still a nice crowd, and this is supposed to be quite an interactive session, so it's actually nice to have this number of people in here. So when I sent in the proposal for this session, it was the life and times of an architecture, because I'd been thinking about how architectures come into being and what are significant moments in their life cycles. And then when I started to actually develop these thoughts, it turned out that actually what I was looking for was these significant events in architectures that are common between the old-fashioned way that we did architecture, or doing architecture in a more traditional waterfall-like context, and in an agile context. So this is why I gave this the subtitle, Finding the Common Ground Between Traditional and Agile Architecting. So in my work, I do a lot of teaching of architects. And I noticed increasingly that from time to time I would say something to a class of architects, and all of them would be very nicely agreeing and nodding, and then suddenly one of them would say, "Oh, that doesn't apply to me." Even though I knew from the conversations we had before that yes, it did apply to them as well. But I had used a banned word. I had used a word that would not fit into the worldview of that architect. Like the word project, for example, is very dangerous. If you are talking to architects who work in an agile context, and they hear the word project, then suddenly they think, oh, but I don't work in projects. I work in a stream of improvements. And they would say, oh, but in that case, if this is about projects, it's not for me. So I have been thinking about how to sort of unify these worldviews and to extract the commonality in the life cycle of architectures. And that is what this talk is about. It's also work under construction. And so I would really like to pick your brains as to what words do you use for these terms? Do you recognize what these moments in the life of an architecture, and how do you deal with them? So once again, please be interactive here. So here is my introduction slide. My main task at CGI, by the way, is a worldwide IT services provider. 60,000, I think almost 70,000 employees worldwide. And we work for governments, for big corporations, and also for smaller corporations. And we do all kinds of IT-related work, and nowadays we are really focusing on helping organizations in their digital transformation efforts. My main task in that organization is to review our solutions just before we are committing to them towards our clients. And that is also that work I've been doing for a long time, more than 10 years. And that's been the basis for a lot of the material I have developed, because that's the advantage of being in that position, is that you see a lot of solutions, you see a lot of methodologies passing by, a lot of domains, a lot of technologies, etc. So I've been able to sort of harvest a lot of things that I saw passing by. And so that's why I also became the guy who standardized and tried to improve in architecture practices. You see at the bottom here some of my hobbies. The violin was already mentioned. So if you are interested in any one of those, we can talk about it over dinner or something. Right, so let's first have a look at what we architect. So this is a software architecture conference, right? So for some of you, I know that is quite a strict boundary. You architect the internal structure of software. However, the architects that I meet and that I review solutions of, that I teach about architecture, they do a lot more than that. Some people call all of these software-intensive systems. I guess they are. So I'm just wondering whether you would recognize, who of you would say, well, we are doing purely internal structure of software. We are just a pure software architect. Yeah, we have, okay. And how many of you are also designing software continuous integration, continuous delivery pipelines. Yeah, we have a few more of those. Who of you are designing IT infrastructures for application landscapes? Okay, that's less. Embedded systems, anyone? Ooh, that's nice. Quite a crowd of those. Integrated software systems. Yeah, also a lot. Enterprise IT systems. Uh-huh. And then we have outsourcing services, sometimes called service solution architects. Oh, I bet you do a lot. Here's an example of I guess you could call it an embedded system. It's a nice example of what I call a solution. I call all of these things solutions, just as a generic denominator for the things that we architect, just to make it easier, because if I say software, I know you will understand what I mean, but many people then think, oh, that doesn't apply to me because I do much more than just software. All right, so the next question is, when do we architect? Now, I know that this is the first context-dependent question, because some of you work in traditional governance organizations, you work in projects. And here's an example of a typical structure for a project. This is, I guess it could be waterfall, could be RUP. You first have some conception or inception. You have some elaboration. You have then the construction, and then you have transformation. So who of you is working in project contexts? Okay, I would say it's about 35%, something like that. And who of you are working more in an agile governance context? Oh, okay, that's about 25-30%. So what is the rest of you doing? What? No, no, seriously, I mean, it maybe sounds like a joke, but I'm really interested in those of you who did not raise their hands. How would you describe your context? Yes? Both. Okay, who of you worked in both contexts? Okay, aha, excellent. So is it a combination, or sometimes one and sometimes the other? A combination. Okay, excellent. So we work in agile projects. Agile projects. I guess that is already the fusion of these two. Okay, good. So here is a typical way that agile projects organize their architecture work. They use a Kanban. I took these 4 Kanban lanes from a website on SAFE, but you could also use other things. And the intensity of the architecture work here, typically, in a project, you would say that the architecture work is concentrated around this elaboration phase, or whatever you would call it, design phase. It starts, of course, already in conception, and it continues all the way through transformation. There's always the need for architectural decisions, right? But here is the real focus. In the more agile governance context, you would say, okay, we have a funnel of architectural epics maybe, or stories, or what you call them. And these come into a backlog, and then you do some architectural analysis, right? And that's where most of the architecture work there happens. And then there's implementation, and of course, then it continues, right? Does anyone have a way of organizing their architecture work, or have one that's different, significantly different from either of those? Maybe you would call it something completely different. No? Okay, good. Right. So just to, I know it's kind of cliche to start with the definition, but I also have noticed that it's actually kind of necessary, because people will, have to explain what you mean by words if you're using them in a different way that some people may use them. So here, I'm talking about solution architecture rather than software architecture, as I said, just not to antagonize the people who do more than just software. And this is my definition of a solution. And I have actually adjusted this definition quite recently to make it, in my view, applicable to both agile and more traditional context. A coherent set of changes delivered to address a defined set of stakeholder needs. Okay, you can say changes to what? Well, that's probably changes to one of these IT-related or software-intensive systems. And the change can be rather radical. The change can be going from nothing to becoming a system, right? But that would also be included with change. The delivery actually is an important part of this. Once again, the coordination of that delivery depends on the governance model that you're using. And you could call that delivery scope called in a value stream or in a project or a program definition. It may be governed by a contract or whatever, right? But for the architect, does it really matter that much? Yes, some things are different whether you are working under a contract or in an organization that is working on a pre-financed value stream. But in the end, you still have to make these architectural analysis and decisions and make sure that they are executed. So how are these solutions defined? Here we see some significant differences, mostly, of course, in names, but some people say they are defined by an architecture epic, right? Or an architecture story. Are there people who are working in an agile kind of environment who use a different word than this for an architectural thing, an architectural solution that is defined by that?
Even on the question about the previous slide, do you do something differently? In our case, there is usually a phase zero kind of a place, yes, where we overall define general direction of a solution overview.
Right.
We call it a solution overview.
Solution overview, and it's created in phase zero.
Right. It's usually a phase zero kind of a thing. Sometimes it creeps into phase one, because architect is also working independently. And what this person is doing is they're generally thinking about overall solution, including the deployment and everything, and they're describing in very loose terms how we are going to address the stakeholder needs.
Okay, so you would add to this definition of where is the scope defined as you would add to that a sprint zero or phase zero, right? Okay, thank you. Oops, wrong button. Okay, yes?
I would say some approaches that start with enterprise architecture would define capability, then maps to epics and features down to stories.
Capability.
It depends on what framework you're following.
That's exactly the kind of additions or that I'm looking for. Thank you. Capability.
Or the concept of product lines. You kind of take the SEI, definition, if you will, where you have some number of systems, potentially large number, that share some commonalities, but also have some variability. And your architectural approaches, we've been dealing with that, at least in our organization, is quite different than your architectural approach for, and I'm just building a system that meets a set of capabilities.
So where would the scope of that architecture work be defined in your case?
It would be based on an assessment of some number of systems that are believed to be in the product line.
Is it like a product line definition, or?
So there would be a separate product line architecture.
Right.
That
okay.
would have system architectures that would be derived from.
Okay. Thank you. Okay, so I guess now we've covered everyone here. Everybody feels at home in either one of these ways of defining a solution. Okay, let's move on. The next question: how do we architect? So here I'm not going to ask you how you architect, because we have a lot of time. We have 90 minutes, and I have only 30 slides. But I don't have time, I think, for that question for each one of you individually. I have just here sort of summarized what I've seen happening, that we have actually focused our architecture work not so much anymore on the creation of an architecture model, but more and more on we look at architectural decisions as the primary deliverable, the primary output of our work. And that's a development that started About 12 years ago, around 2005, there was a first publication about architecture as a set of design decisions. And the basic rationale, the basic reason why we look at architecture that way is that it lowers the cost of change. It's an economic reason to do that. If we document not just the outcome of our model, the outcome of our architecting process, but also the decisions that go into that architecture, then it becomes easier to deal with change because we can always look back, oh, why did we take that decision at that time? The reasons that were valid at that time, have they changed? Are they still valid? And if you don't know those reasons, if there is no documentation of that decision as a separate entity, then it becomes quite hard to later on revisit that and see, okay, can we actually change that? Why again did we make that decision? Right? It lowers the cost of change if you actually document your decisions. I think Michael Keeling tomorrow is going to have a session about this topic itself. I'm wondering how many of you are actually separately documenting their architectural decisions, separate from the outcome of the architecture process itself? Okay, that's about 20%, I would say.
Part of an architectural design document. So
the decisions end up in the architectural design document, but are they also recorded before that, or shared with people, or? You would think so. So how are you sharing these decisions? Apart from summarized at the end of the process in an architecture document, how are you sharing these decisions? Are you using a wiki or a SharePoint list, or?
Well, no, we have a two-step process of socialization session where you socialize the planning solution for the options you're looking at, and then a go, no-go type session to finalize the design, here's the decisions we've made, and either get approval or, oh gee, we need to go back and review again.
Okay.
So those are our decisions. I mean, that's how we document them.
So all of the decisions are sort of, they are packaged together and then approved at in one file sweep. Okay, right. Anyone sort of have a mechanism for sharing those decisions as they are made?
we have formal gate reviews for large programs. So there would be a PowerPoint presentation that would incorporate all those decisions.
Right.
And it would be reviewed by several people.
Okay, so yeah, okay, that's similar to what the other gentleman said. That's the traditional way of doing it. What I'm trying to figure out is, are there people who are doing it more up ahead? Yes.
My scrum teams are doing spikes, they're like little experiments, and then they come back and we review it in our stand-ups and figure out, okay, we figured out that doesn't work, so what do we need to
Yeah. So, but it stays informal. It's done in non-minuted stand-up meetings, right? Okay, right. At the back, you.
We do the same, but then we include it in our Python notebook notes. So it's
okay.
documented in
So
there.
you're using notebook. Yeah, right, excellent.
And then during a sprint, we'd document in a JIRA issue, but then it would make its way to a Confluence wiki, toward the end.
Right.
And that's in the last year, so it's more recent.
Excellent.
So we don't do it all the time, but we try. Sometimes we'll capture it right in the SysML model, and then in another part of the model, there's a table of all these decisions that are linked back to a specific part of the model.
Right. So you have like a plugin, or you just use a comment field, or okay. Yeah. Excellent. Thank you. Okay. Right. So the next question: why do we architect? And this was the topic of my talk last year when I accepted the Linda Northrop Award. Is architectural is what do we do it for? What is the business reason? And my conclusion was that the business reason for doing architecture is to increase risk and cost control. And that has a number of consequences. For example, we measure architectural significance by risk and cost, right? And that's a combination of two views of much more famous people. Grady Butch saying architectural significance is measured by the cost of change. I think we saw that on 2 separate talks already yesterday. And George Fairbanks, who was here in the same room this morning, saying architectural significance is related to the amount of risk, right? Actually, both are true. And so we are saying it's risk and cost-driven architecture. And actually, that really works. If you do, Mr. Raymond Slot has done some research into that, and he shows very convincingly that projects that do apply architecture practices have a better control of risk and cost, better predictability of the solution cost, less budget overrun, less trouble project, etc. Right? The most elegant way of stating it, of course, is the way that Martin Fowler does it. Architecture is about the important stuff, whatever that is. All we're doing is seeing important, actually in economic terms, means risk and cost. So all of this leads to this architecture microcycle. This is basically the workflow of the architect, of the architectural decision-making process that we have in our approach, risk and cost-driven architecture, where you identify and prioritize architectural concerns. And this is what creates your backlog of architectural concerns. And then, of course, that feeds into your workflow where you research possible strategies, decide the best fitting strategy, eventually leading to your main output, your main deliverable, your architectural decisions. And the risk and the cost significance goes into the prioritization of this backlog. So rather than the product backlog, which is prioritized by, typically by business value, we have a separate architect's backlog. And why is it separate? Because these are different things. These are not activities. These are concerns that need to be addressed, and they need to be prioritized in a different way based on risk and cost. So that is what most of my previous talks have been about. So let's not go into that too deep right now, unless you don't understand it at all. No? Okay. Right, so let's look at this next concept, the cone of uncertainty. This is one of the things that got me into trouble with some of the agile architects in my class, and really, which actually is really nice, right? It's if you get into trouble, if people say, have strong feedback on what you're saying, that actually makes you think, and that makes you improve the way you look at the world. And this is what happened here as well. So the cone of uncertainty is a concept originally invented by Barry Beam, but first called cone of uncertainty by Steve McConnell. And it represents the flow of time and the amount of uncertainty that there is. Originally applied to the uncertainty in the estimated cost of a project. But you can also have it applied to uncertainty about other things, such as requirements or feasibility of technologies or whatever, right? And so the cone of uncertainty is something that is common to every solution lifecycle, right? It does not only apply to projects. It also applies, for example, to an architecture epic that you are working on in an agile context. It starts out with a lot of uncertainty into, is this architecture really needed? Is this architectural change really needed? How much is it going to cost? Is it really worth it, etc., etc. And actually the purpose of architecture is to speed up the narrowing of this cone of uncertainty, right? Increase risk and cost control. And we do that by researching strategies to the architectural concerns and making architectural decisions. Each architectural decision will reduce the uncertainty and thus, make the funnel smaller at that point.
So what is the uncertainty about?
The uncertainty?
Is it about the architecture or the overall project, the solution?
Yes, all of those. All of the above, yes, yes. So the architecture itself, there's uncertainty until you have made these architectural decisions. There's uncertainty about that. The project has uncertainty, which also in the beginning is larger and then becomes smaller, about its cost, about the time that you need, the number of people, etc. and the solution has uncertainty about its feasibility, the value it's going to bring to the organization, etc. Right? Yeah, all of the above. Right. So looking at architectural decisions through this cone of uncertainty, we can see a number of interesting things. And not all of them are nice. They're interesting, but actually not very nice. We start with the architectural decisions that have the most impact, right? Doing anything else would not make sense. This is why we prioritize our architecture concern backlog by risk and cost impact, because we want to first make the decisions that have the most impact. Because if the first decisions drive the later decisions. If you start out with the less important decisions and let them drive the more important decisions, you're sort of putting the horse behind the cart, as we say in Dutch. Is that an English expression? Okay, excellent. Oh, okay, right. Thank you. The architectural decision impact starts large, and then, as more and more decisions are made, the impact lessens. The available knowledge starts small, and as the project or epic analysis or whatever we are doing, or whatever you're calling what you're doing, goes on, then we gain more and more knowledge. For example, by trying things out, by making a spike, or by doing some research. This can be, office research, or by actually doing it. Available knowledge increases. And that combination leads to this very nasty predicament. Because our architectural decisions are all based on incomplete information, but the highest impact decisions are taken while the least factual knowledge is available. And that is the reality for the architect, right? And this is the way Philippe Cruchten has formulated this. And this has as a consequence, among other things, that we are bound to make mistakes. Well, not mistakes, things that after the fact, after some time has passed, turn out not to have been optimal decisions. Calling those mistakes actually is a mistake. That is what Kahneman calls outcome bias, right? We think that if we know the outcome of something, that we can then judge whether what has gone before has been done correctly. That is not true for architects. The third line in this graph, the number of decisions, is you start with very few, very high impact decisions. Why do you make so few? Well, because you really want to make the right ones there, or try as best as you can. And then the number of architectural decisions continues to grow until actually you have made most of them, and you're still making decisions, but maybe you don't want to call all of them architectural anymore. So this is why we have a decline after that. Right? Okay, so I'm using this cone of uncertainty to illustrate the life cycle of architectures, independent of the governance context, using the metaphor of the human life. And why such a strange metaphor? Well, first of all, because it's fun, but also because actually removing from the actual, context, and well, what am I trying to say? I'm trying to say that creating an extra level of a layer of abstraction here in talking about these things actually makes it easier for us to talk about these things without knowing what is the context, right? So if I'm talking about the marriage of an architecture, I mean that's the moment when we commit, when the organization commits to that architecture, right? And that moment in agile world is called something else than it is in traditional world. But if I just say marriage, then I have one term and I can use to describe that moment, and you know that it applies to all of you, no matter in which context you work. So this is why we're making this analogy. So we start with the birth. The birth of the architecture is when we know that there's a stakeholder need and we are actually thinking of the first solution concept. Then we go to graduation, which is the moment when we get approval. We are making the business case. We are deciding that, yes, this is worth doing. The third moment is marriage. And marriage is when we commit to the architecture. That is the moment after which changing the architecture becomes very expensive, right? That's marriage. Changing after that is much more expensive than changing before that. And then we have career and home life, and there's a lot of stuff going on there as well. We get kids, and these are revolutionary changes. And you see there's some spikes here in the cone of uncertainty. It's no longer smoothly getting narrower and narrower. No, we are suddenly getting all kinds of new uncertainties, right? And then we finish with legacy. I don't have a slide about legacy, but I leave it to your imagination as to what that means. Right. So let's start with birth. So this is actually not my birth. I didn't want to do that to you, but this is a few months after that. Okay, so what are the typical, I'll start with this. What are the typical concerns that we have as architects at the birth of our solution? Well, first of all, what do the stakeholders need? We need to sort of get our heads around that. And then we have to have some idea of how to give that to them, right? So the typical output at birth is business goals, scope, and your first solution concept. So what do we call this in the two governance models that we have been discussing? Traditionally, well, those of us who are working in Prince2 would call this moment the project brief moment. How many of you are working with Prince2-like projects? Maybe that's something that's more popular in Europe than it is here. Really? I thought it was UK-based. Huh. Prince2. Okay. Right. So this is interesting. So what would you call that here? What is that? The first description of a project that has not yet gotten business approval, but that is there just to, sort of puts things in a row for people to decide about.
Call it a project intake form.
Project intake form. A charter? Yeah? Okay. Thanks for helping me make all of this much more complete. So PIF is something that more of you are familiar with, right? Or a charter?
We actually make the charter part of the project.
Thank you.
I have a question. In some of the things that we do, it starts out as proposal. A customer comes in and says, gives a request for proposal.
Right.
Okay, and a proposal package put together with concept, with estimate. And so I'm struggling with where that would fit. Is that really for the solution, or is it
That's an interesting one, because usually by the time you have a request for proposal or an invitation to tender or whatever you call it, there has already been almost a complete architecture cycle before that, because on the business side, on the demand side, there has already been this whole cycle of thinking of birth and actually thinking of the structure that we would need, etc. But usually at a higher abstraction level. But I will put it here, RFP, or maybe RFI, request for information, which usually precedes that, might also be a good place where you say we capture, some kind of the business goals, the scope, and the first solution concept is captured in there. I think that's a fair one, yeah. Anyone else?
Yeah. Things grow out as change requests. Probably not always formally called that way, but change requests typically has some limit. Sometimes you can explode.
Thank you. A change, yeah. Okay. I don't know whether we are already there yet, that we are formally able to say that, but okay. Let's continue. In the agile world, those of you working in the agile world, what would be your first capture of the solution? What would you call the form or the document or the page or whatever?
So
So at GE, we're using AHA.
Aha.
AHA, does anyone else use that? There's an exclamation point at the end, very cute. But you can create an idea, so people come up with ideas and people vote on them.
Right. And how do you, and that's the start of the governance process for this aha erlebnis, right? Okay. Actually, is that, is, okay, yes?
So we're following the SAFE framework.
Yes?
Usually starts with a new feature request.
A feature request, okay. Right. Feature request. Anyone else? No? Okay, maybe let's go into the next one then. Yes?
So is this where you would capture constraints or overarching governance or other things like that that will drive or dictate certain architectural solutions or decisions?
No, I think not yet. I think that would be the you need those before graduation, right? Graduation is the approval of the architecture. It's.
I think they need to be part of your going in understanding of what it is you need to do, because they're gonna. I said they could easily either dictate certain decisions or drive them certain ways, or require compliance with other architectures, things like that. So that's kind of a going in thing you need to know.
So you would say that would like be something that you add to the business goals as business constraints or something like that, maybe. Yeah.
Are you by any chance referring to the architectural principles or some standards that you want to bring in as part of your enterprise plans and enterprise standards?
It could be standards, it could be other, I'll say, higher level architectures, there could be defined enterprise architectures that are pushing product line architectures that are requiring you to be compliant.
So if you would be writing an inception document or a project brief, that information would be captured in there. Okay, yeah. Thank you. Okay, let's go to graduation. So, so the typical concerns that you have at graduation is it worth doing this, and are we confident that the risk and the costs are under control? This is the business approval moment, right? Where we all agree as an organization or as a team, as a self-organizing team maybe, that we agree, yes, this is worthwhile. So the typical output there is a business case, which can be high level, a solution design, so the solution, no longer a solution outline, but we actually now have a design, and a delivery concept, some idea of how we are going to deliver that solution. Otherwise, we just cannot make, those are actually two things that we need to make that business case. So what would we call this in the two paradigms? In the traditional paradigm, we would call that project initiation documentation, or a plan of approach, I guess, is another way of putting it, or an end of elaboration. In RUP, I'm quite familiar with RUP. I'm actually a little bit sad that RUP seems to be completely disappearing, because I still think it's an excellent way of, an excellent software development life cycle, and you can actually do it in an agile way. And especially this elaboration phase and the exit criteria for that are really nice ways of defining basically this moment of graduation. And we have an architectural design. In the agile world, well, I've seen things like value statement or ROI assessment.
We write a press release.
A press release.
Yeah, it's like, what is this going to look like when it's deployed? It's like a fake press release, so that everyone can knows what we're building.
Isn't that more part of the birth?
Well, I mean, it tells the value statement.
Oh, okay, right. Okay, thank you. WordPress, okay. What other names are in use for this graduation phase and the documents that we're using? Or they don't need to be Word documents. They can be, posts on the website or.
Question. Is this when stakeholders part of that business case approval?
Yes, absolutely, yes.
So in the traditional waterfall, there are a series of reviews with the stakeholder, PDRs, CDRs, things like that. I don't know if that falls into this category.
Yes, absolutely, yeah. So you would say there are
Preliminary design reviews, there could be a system requirements review.
right, right, design reviews. Well, they go into this, right? And that's very obvious because you want to decide whether, whether actually the graduation takes place. Does the architecture and the solution fulfill the requirements here? What? Solution review. Right.
Things like the kickoff meeting.
Kickoff meeting, yeah. So that could be here, it could also be at marriage, right? All right, so what do we do at graduation, right? So basically, graduation is very much tied to this cone of uncertainty, because usually there are some criteria by which our stakeholders decide, or the organization or the team decides that yes, we are going to do this. This is worthwhile. You could call it a budget approval moment, except that the word budget, once again, is very much dependent on which paradigm you're using, so I'm trying to avoid that. This is why we use the word graduation here. There is an acceptable risk threshold. So basically you're saying that the cone of uncertainty has to have narrowed to a certain level to be able to say, yes, we're going to do this. Actually, the architecture, of course, is part of the evidence that that threshold is actually reached. You need the architecture, some level of architecture description, to be sure enough that those risks are enough under control, sufficiently under control. So here are some tips. Document this evidence in architectural views that address the uncertainty-related concerns. So what we are doing in our approach, risk and cost-driven architecture, is we have identified two standard views to address the concerns that always appear at graduation time. And those views we call the operational view, which basically says, this is how the solution is going to run, and the delivery breakdown view, which basically says this is how we're going to get there. So I'm using the word view, and I'm sure most of you are familiar with that, especially those of you who have had some education or have read the SEI books, and also the books, for example, by Rosensky and Woods, etc. Actually, all of these architecture documentation methods use the concept of views. So viewpoints address the concerns per stakeholder or per stakeholder group. And so what we're doing at graduation time is we are seeing always the same concerns. At graduation time, the concerns are, is this affordable? Do we know how to get there? And are we confident that the risk and costs are under control? And if these are so common, these concerns, then why not create viewpoints to address those concerns, because then you can use them basically for all of your solution. And that's what we're doing. So this morning in this excellent keynote, we saw the 4+1 views model, right? Those were invented also by Philip Cruchten, by the way. And they are, the 4+1 view models are specifically directed towards concerns that always occur in a certain phase, in basically the elaboration phase, that's what they're made for, in a software development life cycle, right? That's a little bit further on in the life, right? We are only here at graduation. We are not yet ready for the 4+1 views. We don't need them all yet. We don't yet have those concerns. Those concerns will arise next once we have decided, yes, we are going to do this. So these two views that we are talking about here, the 2+0 views, you could call them, are meant to address those concerns. Am I making sense? Okay, so let's see what's a little bit closer into what are those views? What are those standard views? Well, in the operational view, one of the things we always need is the context diagram. And there are basically two questions that this context diagram answers. What's in scope and what is not? This is essential if you want to discuss a business case, because if you don't know what exactly is in scope and what is not, then you cannot determine how much it's going to cost or whether it's actually going to fulfill your needs. So that's the solution boundary. And what external systems and actors do we have to deal with? Because we want to understand how this solution fits into its context. So here we see an example of a context diagram. I just, copied this from Wikipedia. And you see here the solution, the context diagram. This is a pure context diagram because the whole solution itself is only one circle. And that's fine, because the solution boundary then is this circle, and these are all the external entities. So who of you draws context diagrams? Really? Less than half? No? I always wonder, without a context diagram, how do you know where your solution ends, right? Or what is in scope and what is not in scope? Or is it not important in your situations? Ah. Oh, but that's fine. Okay, yeah, that's fine. But the solution boundary is clear in it. Yeah, I think that would be essential. You need to know what is the solution boundary and which lines cross that solution boundary, because that tells you what you have to deal with in the outside world, right?
We tend to have our scope defined, RSD requirements, specifications. Actually, this is in the scope of our scope item.
Right, and does that have a context diagram?
No. The diagram.
So that's part of it.
I was just going to add that when you're working on an agile stream of continuous delivery, it makes your context diagram really squishy because it changes. We go through graduation every program increment, which is every 3 months. We agree to new scope.
Yeah.
And so we try to do this program increment context diagram, but things are changing all the time. So
Right.
these artifacts work very well for traditional dev projects, waterfall or RUP, but they get harder to complete for continuous delivery work stream.
Right. So here this is an instance of what I was discussing, where people say, "Oh, this doesn't apply to me," right? So I agree with you. If the solution that you're working on is not so much about building a new system, this is clearly about building a new system, right? And then the context diagram is very clear. It's not squishy at all. But if the solution remember a solution, a coherent set of changes. If it's actually a coherent set of changes to an existing system, then this context diagram becomes not so much, it becomes different. Actually, it requires you to show the scope of your solution, which means that you have to show which elements in the existing situation are changing. But that's still a solution boundary. Okay? Right. So what's the other thing that we need in the operational view? Well, we need an operational decomposition. We need to know how the runtime elements that we are changing or delivering or creating depend on each other and how the information flows through the solution, right? Back in the 70s, somebody came up with an idea on how to draw pictures of this, and they called it a data flow diagram. Some of you remember that, right? The good old DFD. I still make them because I still find them very informative. And in transient solutions, right, those are the type of solution that you're talking about. The solution itself, it doesn't become a new system. It just becomes a coherent set of changes to an existing landscape or an existing system. Then actually you will need to draw two of these. You need to draw one operational decomposition of how the system is currently working, sometimes called the current mode of operation or the as-is, and one for the new situation. How is it going to work? Future mode of operation or the to-be. Right. The second view, so these two diagrams are part of the first view, the operational operational view. The second view that is for a different concern. that's the delivery breakdown view. Remember I said we need there's actually two standard views that always are needed to address the concerns at graduation time. This is the second one. It's how to get there. It's how can the solution be decomposed to manage delivery. And we are using a separate diagram for that, which we call the solution breakdown structure. This is needed to understand the deliverables that we will need to actually make this story work, to make this solution work. It's the basis for organizational allocation, by which I mean, we need to understand which of these elements in this solution breakdown structure is delivered by who is taking responsibility or ownership of that, which teams are involved. Story decomposition, solution costing, etc. Solution costing, of course, needed to make that business case. Okay. Any questions about graduation? Okay, let's move on to the next phase in our lives. Marriage. So here I had a little dilemma, because this is my first wedding. And of course I would rather put a picture of my current wife there, but it would not fit in the, the chronological order of the pictures, so I have to do with my first wedding. Anyway, I was much prettier at that time as well, so. Okay, typical concerns. How confident are we about this architecture and what are the alternatives, right? So, yeah, I hear some of you mapping all of this to the real human life, human moment of wedding. So the typical output is a comparative trade-off analysis, elaborated solution design, and a design review. Here, actually, you see, I've separated these two things that are very often combined. What we actually usually do, is we are combining graduation and marriage. We would never do that in real life, would we? Right? They are two different things. There's different concerns at play here, right? But for some reason, and I think there are some good reasons, organizations tend to put the two together. So, what do we call the output of this? Well, traditionally we call it project initiation documentation again, or elaboration, or critical design review. There you go. In the agile world, there are some evaluation moments, review moments, etc. Refine understanding. Any other terms that you guys are using for this? Do you understand the difference between graduation and marriage here? Okay, good. Well, if you think of any other terms when we're discussing this, then yes?
Would this be a POC that you would do, or is this like MVP1?
MVP1, what is that?
Minimal viable product.
Minimal viable product.
Just
I don't
to
know.
verify that it's going to really work.
Maybe. I don't know. Yes?
It would, and I don't know how to apply it to marriage, but it seems like it's really a series of commitments, right? I mean, you can commit to certain things that are architectural in nature at some points, and you would want to commit to other parts of it until later. And in fact, your later decisions will be influenced or possibly driven by your earlier ones. So it's not so much of an event.
Right.
As a
Sometimes it just happens. You look back and you say, oh, actually now we're committed, right? So I agree with you, but the thing is, of course, that these architectural decisions, I mean, you would like to commit to them one by one. You would like to say, okay, let's only commit to this part of the architecture yet, and you delay committing to the other parts as long as we can, but they're often closely coupled, right? And that's a real problem here. So this, if you look at the cost of architecture change curve here, then there's usually a moment after which it suddenly becomes a lot more expensive to change. And you see here that I have drawn another graph, the realized solution. And very often these two are tied together, right? Because once you start realizing a solution, then suddenly you no longer only have paperwork. Your architecture is not just paper, which is very cheap to change. No, it's also code, which is a little bit less cheap to change, right? Now, I'm not saying that the two are, that you cannot really uncouple them, because of course you would like to also try to realize a little bit of the solution without raising the cost of changing to the architecture, just to try out whether your architectural decisions are okay. This is what we build prototypes for, but this is also why we would like to start building as soon as possible, especially in an agile context. Right, so of course what we'd like to do is know when this moment arrives. It's always better to know when it comes about than to look back and say, oh, now we cannot go back anymore, right? And just before that moment, you would like to get an outside view. I'm referring to Kahneman here. Those of you who have not read Thinking Fast and Slow, I don't have the picture of the book here, but I don't like taking pictures of books, unlike some other speakers. That book, Thinking Fast and Slow by Kahneman. Kahneman is a Nobel Prize winner in economics, but he is actually a psychologist. And he has sort of summarized his whole life work into one great book with that name, Thinking Fast and Slow. And it is about how people make decisions, how humans make decisions based on uncertain or incomplete information, how we assess risks, and how bad we are at that, and actually how we can combat that badness, and how we can get less bias in that. This is actually essential, I think, to architects. We need to understand these biases. We need to understand how we should assess risks in a better way. Anyway, so one of the ways you can do that is doing an ATEM, right? Since we are at an SEI conference, of course, I should mention the ATEM there, but there is loads of other ways to do architecture assessments. And actually, the speaker before me in this room had a very nice example of that.
Shouldn't we do the architecture assessment before we get married?
Yes, yes. Before crossing this line, yes. Thank you. All right. So the question, of course, is how many architectural decisions should we make before that commitment, right? Here you see two models. One is that we make as little decisions as possible and then quickly get married, and the cost of architectural change goes up then. And the other model is that we actually want to make sure first, very sure, before we get married. And there, which of these is the right model? C. Same. Well, they're not really the same. It depends, right? That's the answer to most of the questions that I ask you, by the way. But so what does it depend on? Well, there has been some very nice research by Barry Beam. You see, I have some favorite authors. Where he looked at his huge database of projects and all the attributes there that included things like hours spent on design, hours spent on realization, but also success factors of projects, etc. And he actually found three factors that determined the optimal amount of decisions or design time before you committed to an architecture. He calls it a little bit different. His article, I think, is called How Much Upfront Design. But I'm trying to avoid using that word because the word upfront design, once again, for those working in an agile project, is by definition bad, right? So let's try not to use that. But basically, he says there are three factors: business criticality, size, and volatility. So the lower the business criticality, or the higher the business criticality, the more upfront design you should do. Why? Because it is more expensive to fail. If it's cheap to fail, fail often and fail early, right? Because then you learn faster. But if it's very expensive to fail, you cannot afford to do that. So you'd better do some more upfront decision making. Size, similar. If you have a very large system that you're architecting, then the number of decisions that you should make before you actually start on or commit to that architecture should be greater. Because it is, if you are making very few decisions and then start building this huge system, it's going to be very expensive to change directions. Large ships are harder to turn than small ships once they get going. So you better know exactly where you want to go before you start making pace. And the third factor is volatility. And of course, if there's a lot of volatility, then it doesn't make sense to do a lot of upfront decisions, because by the time you reach this part of the cone, the environment will have changed. And so all of that work might have been obsolete. So those are the three factors. He has a nice formula with a square root in it and everything. So, okay. Let's move on. Career and home life, fulfilling the architecture, right? We are already in the process of realizing the solution. But we're doing continuous architecting. We're still making architectural decisions. The continuous stream of architectural decisions continues. So what should we do here? Well, independent of the context, once again, there's a number of things that we should make sure of as architects, or that the organization should make sure of if there is no such thing as an architect, right? I should even be careful using that word. But so we should make sure of completeness. All the elements in the delivery breakdown view should be realized. Where should you make sure of that? Well, we can look in the backlog or in the project plan, depending on your your governance context. We should make sure that all of the architectural significant requirements are tested. Where should we look for that? Well, in the definition of done, or once again in the project plan. We should make sure that there is coherence. I guess this is one of the essences of doing architecture, is a conceptual integrity or coherence of the solution. That means that architects or the architecture should be involved in integration, and that inter-team dependencies should be minimized. So we saw a wonderful keynote this morning exactly about that point. Make sure that the inter-team dependencies are minimized. You can only do that if you are aware of the architecture. If you don't know the architecture, you cannot decide how to divide your teams up. You should make sure of communication of the architecture. And finally, you should get involved in risk management. So those are all things that have to do with fulfilling the architecture. Am I missing something? No? Okay. So health and debt control, right? Two very important things in your home life. And I think all of you are at the age where you have already started dealing with this. Health and debt control. So one of my favorite tools for health and debt control of an architecture is this diagram by Philip Kruchten. It's from a talk that he once gave called What's in Your Backlog. And he uses this coloring scheme. Who of you have seen this coloring scheme before? Okay, about 25% or so. I'll explain it. So basically what he says is what is in your backlog, you can divide into 4 segments. The things that are either visible or invisible, and they can have positive value or they can have negative value. By invisible, we mean invisible to the end user, right? So the visible things that have positive value, those are the new features, the added functionality, the nice things for the people, for the stakeholders. They have direct business value. There's also invisible things with positive value, meaning, of course, they are visible to the developers, to the architect, etc., but not to the end user. The end user doesn't see whether there's a caching mechanism, or whether there's an enterprise service bus, or an API. What was it in the architecture we saw this morning? API portal or something like that. API gateway, thank you, yes. API gateway is a typical yellow thing, right? It doesn't add direct business value, it's just there to enable the architecture and to enable the quality attributes. So this is why sometimes these invisible things are called enablers. We also have things with negative value. Of course, things that are visible with negative value, they are things that are just plain wrong. They are defects. And then we have the technical debt, which is the invisible stuff with negative value. And negative value in this case is measured by yeah, it's the interest we pay basically on the debt, right? That's if you pay interest, then it's technical debt. Right, so we're using this coloring scheme. Remember, green is the nice stuff, yellow is architecture, black is technical debt, and red is defects. And we're using this to order our, to keep our health and debt under control. How does that work? Well, here you see a typical Scrum picture. You see the solution backlog with all the nice colors in it. And you see the sprint backlog, which is, of course, determined at the end of every sprint. You see what goes into the sprint backlog for the next sprint. You have your sprint loop here and your daily stand-up meeting and the solution increment. Everybody knows this picture. Well, how does the architecture work fit onto this? And my apologies to those who were here last year because I showed this same picture then. But this is how it fits. The architecture microcycle is there with its own backlog of architectural concern and its output of architectural decisions. This is the microcycle. This is actually the work that leads to the yellow and the black activities in your solution backlog. So, where do the other things come from? Well, they come from here. There's some kind of an improvement intake or whatever, where your user features and your defects come into your solution backlog. Now, of course, who is in control of this gate here? Who decides which elements from here go into your sprint backlog? Product owner, right. What does the product owner prioritize by? Business value. Which color has business value? Green, right. So if we actually apply that principle, prioritize by business value, if we apply that principle naively, I'm not saying that everybody does it, but if we apply it naively, what happens is that all the green goes in here, and the yellow and the black stay here, right? Now, the yellow, okay, that's fine. The architect becomes unhappy because his decisions do not get activated. But what happens with all the black stuff that's in here? We pay interest on it, right? And if we pay interest, that means that actually we are able to make less green here, right? So our velocity slows down. Yes?
I think where communication skills and persuasion skills and business case skills come in, because if you can make the business case for those yellow and black things, then people will understand.
Right. Yeah, so the business case, of course you have to make a business case. You have to translate the indirect value into arguments to actually get some kind of a balance between the green stuff and the yellow stuff and the black stuff and the red stuff in your sprint backlog, right? And in order to be able to do that, you need to anticipate. Because usually the business value of the enablers is further in the future because it enables green stuff than the business value of the green stuff, right? You see here, there's two nice features of this picture that I haven't discussed yet. You see here that this daily stand-up meeting touches this daily architecture microcycle. That is not an accident. The architecture work actually is part of the team, of course. And if you have a separate architect either inside or outside of the team, then this is where they should touch, because the team is one of your primary valuable sources of architectural concerns. Very often, the team discovers that there is an architecture concern that needs to be addressed, and it has to go into this architecture process. Independent of whether that's actually a separate person doing that, maybe sitting in a different part of the organization, or it's actually a responsibility that is taken on by the team itself, and that is, you don't need to have an architect for that, but the architecture work still needs to be done. you see the second arrow here, because some of the architectural concerns, it's better actually if you notice them before they reach the team, right? If we have an intake of these green improvements here, we may discover that they're not that green. That maybe that actually to create this piece of green functionality, we need first to get rid of some of the black technical debt, or we actually need to create a new yellow architectural structure. So, there's a very nice article by Annette Brown, Rod Nord, and Ipek Oskaya. Ipek is here, by the way, which basically says, it talks about just enough anticipation, which it talks about how to use dependency analysis and technical debt control and economic reasoning to look further ahead than just the one sprint. And here we get back to the two paradigms, because this is actually a form of what I call architecture road mapping that you can do independent of whether you are in an agile context or in a more waterfall-like context. Of course, we are talking about home life, about the situation where we already have a product that is alive and kicking. But the only concession that we have to do is we have to anticipate, right? And I say, why is anticipation a concession? Well, of course, anticipation is not a concession to the architect, because that's our job. But in some agile methodologies, anticipation is frowned upon, right? Yagni is the term that you sometimes hear. Don't think too far ahead. The world is going to change anyway. You ain't going to need it. Yagni. Okay. So now we get into the final stage. You don't have these buckets here in the United States? No? Actually, it's apparently they really, my kids really liked it. Anyway, so what are the typical concerns that we have when we have revolutionary changes, like children? And these can be things like huge refactorings. We need to port the whole thing to a completely different platform. Actually, we need to rebuild the whole thing. The typical concerns there are what has changed since the previous generation, and how do we prevent damage to the existing status quo? This is a very important concern in revolutionary changes in a running architecture. Typical output here, once again, is business goals, scope, and a first solution concept. The child is a solution in its own right? So we are actually going back to the birth. Yes, getting children is a form of birth. Also in solution architecture. Right. So we have the same, forms or formats of capturing that we had before, that we have already discussed. So I don't think there's any need to go over that again. But you see that one architecture begets the next one. So those are all the slides that I had. Well, I actually have hundreds of more slides. But these are the slides that I had planned to show you within the time allotted, which I have succeeded in. Are there any questions up till this point? Or comments? Or yes, Beth?
So, I'm trying to figure out if you go back one slide or two slides. If something is so big, a feature is so big that it causes a big yellow box to be created, would that be considered a child?
It could be, yes. Of course, this is all a matter of how do you apply the metaphor here, right? But sometimes, yes, this becomes a solution in its own right. A feature like this, or this architecture story here, might be a solution in its own right, which requires its own business case and its own life cycle, yeah. So maybe I should say a little bit more about this diagram here. I actually wrote a column in IEEE Software Magazine last autumn. So this is the November-December issue, which explains this picture. But what we do here is we anticipate by talking to the stakeholders about what are the events in the future that have an influence on the cost or the risk or the value of your solution. And those are the basis for the timeline that we create for the architecture road mapping. And we're creating just enough anticipation by calculating back the dependencies of these events with the solution items that, or the solution improvements that we have to realize. So if we know that competitor releases the next generation, a very shiny new version of their product, and we do not want our product to also to lose a lot of business value at that point in time, we actually need some nice green features to be in there in time, right? So there's this dependency arrow here. But these features we can only build if we first have improved our architecture. And that's this yellow thing here with the A in it. So that's this dependency arrow. So if we only start building this architecture element here, then we are too late to actually beat the competition, and we are losing a lot of business value in our solution. This is architecture road mapping, basically. You recognize this? So what we noticed when we started doing this was that, well, you know how difficult it can be to convince stakeholders of the business case for technical debt reduction, right? The first question, you say, okay, you know, we have this piece of rotten code in here, and we really need to refactor it. And the product owner says, well, why? It works, doesn't it? Okay, so that's the first question. Yeah, but if we don't fix it, okay, so you have all kinds of arguments. As an architect, for you, it's completely obvious that we have to do this black work, this technical debt reduction. But it's very hard to convince the stakeholders of it. But actually, sitting down with the stakeholders and discussing this anticipation viewpoint, asking them what are the events that will impact the cost or the risk or the value of the solution, that will help you tremendously with with managing the expectations. It will also help the product owner because the product owner, of course, is just a representative of the stakeholders here. So stakeholder management is key in having a balanced backlog in terms of visible and invisible elements. Yes?
One of the members mentioned about new viable product. The new ideas like the lean startup and incremental delivery. Where do you see the role of architecture, those kind of deliveries?
I'm not sure I understand the question.
So these new ideas like lean startup would say that you get things done and don't worry about getting it right, because getting it done is more important from a business point of view. So how do you see architects working with ideas like that?
Okay, so let me go back to this this slide here. This is the lean startup, right? Make as few decisions as you possibly can, and just start up, and don't worry about getting it right the first time. Okay, so that is perfectly sensible in a situation where that is volatile, and it's not too business critical. Because if something is very business critical, you stand to lose a lot in terms of either money or even loss of life. I mean, I also work for safety critical clients. Then you cannot afford to do this because it's the cost of failure is just too high. Yes.
Yes, over here.
This one? Yeah.
Yes, please. Over here you mentioned that the architecture microcycle is part of the daily ceremony. What will happen if you don't discuss it daily, or you delay it like once a week? How it will impact the outcome?
Yeah, I guess it's not always possible to do it daily, right? I mean, especially if you are in a position as an architect, among maybe, I think the other guy was saying yesterday, 23 teams, one architect, 23 teams. yeah, you cannot do 23 daily stand-up meetings every day. So you have to sort of divide your attention, and you have to find other ways, which by the way, was brilliant yesterday. You obviously weren't there, but how to be an architect without any authority or something like that, I think was the title of his talk. Yeah. So yes, so you have to find a way to keep in touch without having to be physically present every time. It also depends on the rhythm, the life rhythm of your product. I mean, some don't do it every day. Some organizations have this every week.
One concept is scrums. Scrums take many scrums, and then one person from each of those scrums goes to
Yes.
a bigger scrum.
Yeah.
Have those discussions there instead.
Yeah. So of course the trick of getting the right balance here, there are a number of well-known methods to achieve that. One of them is to reserve a certain percentage of every sprint for invisible, for enablers, right? The problem with that, of course, is that sometimes your enablers, your black and your yellow blocks, are bigger than 20% of one sprint. So then you cannot fit them into that, and you have to try and cut it up, but not all architecture improvements can be easily cut up into small pieces. So another trick that you can do is actually rotate this. Have 3 normal sprints with all kinds of green stuff, and then have a sprint with only the black and the yellow stuff. Some people call this the technical sprint, or I've heard different names as well. The advantage of that is, once again, expectation management, because the product owner knows that, oh, in that week, they will do nothing for me. So that's you know, he can also manage the expectations of his stakeholder, etc. You can do that also with multiple teams working in parallel, where they actually they take turns doing the technical sprint. The danger of that is, of course, that all of the quality work is delayed until this technical sprint, that people actually do sloppy work in the regular sprints. That is absolutely not the intention of this planning of technical sprint. Beth.
So I'm just going to confess I'm now a product manager. So I work really closely with my architect, and I understand all the yellows and the blacks. Mm-hmm. And so I make sure that they are doing those along with my features, because I know the issues. And I think if you as architects take the time to educate your product managers, we're not that bad. You know, we're not the enemy, and you can really make a good partnership and then get as many things through as possible and keep a nice stream. So I just want to be the voice of the enemy just for a few minutes here.
Yeah, I fully agree. What I'm trying to give you, for example, with these types of practices, is the tools to educate your product owner or product manager. By translating it into their terms, into the risk and cost and value aspects of what they are trying to achieve. I mean, talking about layers and about clustering criteria and API gateways is, you know, it doesn't make much sense to most product owners. Translate it into risk and cost and value and timing aspects. Okay, we have 5 more minutes. Yes.
Back to marrying earlier or later.
Right.
Yeah, it says for the size of the project, if the size is larger, if the business criticality is higher, you'd want to marry later. Is that what that's saying?
Yes. Well, you want to put more thought in before you commit, basically.
Okay. I don't know. That just seems the opposite to me. It seems like if the size of your project or the business criticality is very high, it seems like you would want to marry early so that you could flesh out the other decisions around that. You would want your architecture to be your foundation, let's say, and you would be married for a longer time.
Um, if you marry,
Keeping with the
if you are you saying if you put less thought into your marriage, you will be married for longer? Is that? It, but this is a lot also about the timing of architecture decisions, right? I actually have a spare slide for that. Maybe that will make it a little bit clearer.
There's not the plot that you had that as you move forward, what you know increases.
Yes.
In the project too. So I think that ties into waiting on your decision because you'll know more about the project as you move to the right.
Exactly. So this is what you want to wait until your knowledge grows before you're married. That's basically before you commit to the architecture. This is why later marriage in that case would be better. So here is a slide about the timing of architectural decisions. Here you see this little graph here. And basically the timing of your architectural decisions, and this is about a single decision, but it can also be about committing to the whole architecture. The same arguments I think are valid. As the time goes by, the risk of making the wrong decision decreases because you gain more knowledge, right? So this is why you want to delay your decisions, to make the risk of making the wrong decision as little as possible. But there is always a cost of delay, right? If I don't decide now, then there will be people waiting on me. They will not be able to complete their work, etc. There may be other factors in the cost of delay. So the optimal decision time is when the sum of the cost of delay and the risk is actually minimized, right? So cost plus risk, when that is minimal, that is the time that you have to make your decision. That is the optimal balance between cost of delay and risk of making the wrong decision. The only problem is that it's often hard to know when this time is. If it's past, you know, right? Now, oh, I'm now too late, you know. So this is the way that you calibrate your new toaster. You know, you see this nice little poem here. There's an art of knowing when, never try to guess, toast until it smokes, and then 20 seconds less, right? So if you want to find the right setting for your new toaster, you just sacrifice one slice of bread. You put it in there, you set it to the maximum, you time it, and as soon as the smoke comes out, you stop it and you subtract 20 seconds, right? So if we could do that with our architectural decisions, that would be great, right? We just wait until it smokes, until we know, oh, now it's too late. And then we step into our time machine and we go back to the time that we now know was the optimal time. So that's the trouble here. So once again, just like with the predicament that we always have to make the highest impact decisions when the least factual knowledge is available, we have a similar thing here where we cannot be sure. There is no 100% certain algorithm for us to determine the right timing for our architectural decision, which means that we have to become good at it. We have to actually also be courageous sometimes in making decisions based on incomplete information, right? Architects are very often the source of analysis paralysis because we are not courageous enough there. We have to be pragmatic. I think we can have time for one more question.
Good talk, by the way. Thanks. The struggle that we run into is not the architectural decision-making for a single project. It's the multiple projects, some of which are waterfall, some of which are agile.
Right.
And all with their own release schedules. They're dependent but independent from each other. Thoughts on that? I mean, I think that's a lot of us in here have this same struggle. How do you marry the two in a way that isn't, you know, either budget busting because, you know, everybody's just trying to, you get all the architects in one room and we just all hash it out, which never really quite happens because then you're way too early in your decision making.
Yeah, some of them will be too early, others will be far too late. So what we're doing, what we're trying to do here is to apply this practice to the portfolio level. So now we are having a slightly different look at this diagram. Now the boxes are no longer single stories in our backlog, but the boxes actually are projects and are whole architecture epics, and you can actually use exactly the same practice. On the portfolio level, there are also these events, and there's also dependencies between the projects, and they also have these cost, value, and risk impacts. So that's what we're trying to do. Okay.